Hello, so today I'm going to be talking about moments along a rigid body. Rigid body I want to talk about is the fan above my head. So, as you can see in the video, there's my fan spinning above me, and then here's a still shot of the fan. And now what I'm going to do in order to get the moment of inertia is I'm going to set up this still shot into basic shapes. So the basic shapes I chose was a thin plate and rods that are protruding out. So here is the three-body diagram version that includes all the measurements and where the moment is going to occur in the fan. So the givens that I obtained from the fan was I got the mass of the blade, and I thought it should be pretty light because it's made out of a thin material, and the aluminum metal rods should be a bit heavier, although they are a bit shorter. So as you've seen in the previous diagram, that one side was 70 centimeters, another side of the plate was 15 centimeters, and the length of the rod was 10 centimeters. And I calculated the angular acceleration to be 0.75 radians per second squared, and the way I got that was how long it took from initially turning on the fan and then getting it up to speed. I just timed it, and then using the previous recording, I figured what the angular velocity was, and then using kinematics, I was able to determine angular acceleration. Now, on to the assumptions. So some assumptions that I made about the fans is that it is about a fixed point. All the objects that I chose are completely rigid. I neglected friction and gravity. Gravity was not necessary because I'm only looking at the spin, and I believe nothing should be affected by gravity since every single piece is equally affected. And also the fan was made out of basic shapes rather than all the complex curves that it has in real life. Now on to some equations. So these are equations of moment of inertia for the basic shapes that I chose. So I chose the rod and a thin plate. And in order to get the moment of inertia along the single point that all of the shapes are rotating around, I had to use the parallel axis theorem, and then the final equation of the moment equation is used to get the final moment. Now in the solution, I did the summation of the parallel axis theorem, and for the first line, I did the parallel axis theorem of the thin plates, and since there are 5 of them, I would be adding each one individually. Since they are all the same distance away, it should be multiplied by 5. Same goes for the rods, but it's just a change of the number and the change of the moment of inertia equation that's initially used. So then that gives us the answer of 0.1251 kilograms meters squared, and then on to just finishing it all off by multiplying it by the angular acceleration in order to give us our moment of 0.094. And that is all for the moment of a fan that's in my room. Thank you.